But if I were to give you problems like these, what do you need in order to complete those problems? Yeah, a common denominator. And so when I look at common denominators, 19 is prime. 38, that is what? 2 times 19, right? And so you can see that I'm going to have to multiply this guy by what I'm missing, right? In order to get a common denominator so that I can add those and get this particular one here. If I look at the next one, 15, well, that is 3 and 5. 25, well, that is 5 and 5, right? Another way to write this is 5 squared, by the way. In order to get a common denominator, I need to account for all of these, do I not? So I need to account for a 3, a 5, which that's accounted for there, and I need to account for another 5. Everybody see that? So I actually would have to do 3 times 5 times 5 as my common denominator for this one. And I would have to multiply by what I'm missing. Well, I'm missing a 5 here, I'm missing a 3 here, right? And so when I do that, you could see that your common denominator there is 75. And so that's what you basically do when you are doing common denominators. You are looking at all the factors and you're saying, what am I missing from this particular one and from this particular one to get what's in common, all right? And so now we're going to take that same concept and we are going to do it with rational expressions, all right? Common multiples, all right? Finding the least common multiples or lowest common denominator, right? Least common multiple. When you're given something like this, we have 4x squared minus 36, and we have 6x squared plus 36x plus 54. The best thing to do here is what I was doing with those fractions with numbers, is to just completely factor it and see what your factors look like, all right? And so for this first one, this is actually a special case. You may not be able to see it right now because you have to take out your common factor. But they're both perfect squares, all right? When you are factoring completely, though, you need to take the common factor out first. So what's in common between the 4x squared and the 36? A 4. And you're going to get x squared minus 9. This is the special case here. I have 4. And how do I factor x squared minus 9? X plus 3, x minus 3. All right? So far, so good. What do I have in common over here between the 6x cubed? Yeah, I have a 6. So I'm going to take a 6 out. X squared plus 6x plus what? 9. All right. So I have a 6 on the outside. How do I factor this guy? It's a special case too, actually, right? Now, if I were doing this all together, this is actually not prime. 4 is not prime. Have I gotten in prime factorization at this point? No. What can I break 4 down into if I'm doing prime, true prime factorization? 2 and 2. All right. The 6 is also not prime. What can I break the 6 down into? 2 and 3. And so now I have to account for every single piece of this in order to get a common denominator. Does everybody see that? All right. And so I have to account for a 2. Here's a 2, and that accounts for this one as well. You can use it on a one-to-one basis. That's how you do this, right? So a 2 is going to be in my common denominator, right? I have another 2 that I have to account for. So I'm going to account for that one. As far as numbers go, I also have a 3 that I have to account for. Everybody see that? All right. For binomials, I have an x plus 3 here, right? Which one of those can follow with that guy. But I actually have another x plus 3. Does everybody see that? So if it's repeated, I have to actually repeat it in my denominator. And there's one more piece I have not accounted for. That is my x minus 3. So this whole thing would be my common denominator. This whole entire thing would be my common denominator. And so when I start looking at what do I need for this group to get to the common denominator, I have to compare this to my common denominator, right? Does everybody see that? So if I'm comparing this guy to my common denominator, I have the 2's, right? I have this 2, yes? I do not have this 3. So I would need to multiply this guy by a 3. Everybody see that? That's what I'm missing. I have an x plus 3, and I have an x minus 3, but this guy is missing an x plus 3. So I would also have to multiply this by an x plus 3. And that's the process I'm going to use to figure out what I need to do to get these common denominators between these larger rational expressions, all right? You're going to factor it completely, and then you're going to say, what do I need to multiply by to get this common denominator? All right? So let's try one. All right? They want me to add 1 over x squared plus 5x plus 4 and 5x over 3x plus 3. Like any other fractions, before I can add them, I have to have a common denominator, all right? So before I do that, I need to figure out what my common denominator is, all right? So I'm going to factor these first. I'm going to say x squared plus 5x plus 4, that factors to x plus 1, x plus 4, right? Everybody agree with that? 3x plus 3, well, that factors to 3 and x plus 1, all right? So now, my first step here is to figure out what my common denominator is. X plus 1, that's obviously going to be in it, and that actually accounts for both of these, a 1 to 1, so I have an x plus 1. All right? X plus 4, that needs to be in my common denominator. All right? And then my 3. So this is my common denominator. I have accounted for every single piece of my factors. All right, so far so good. Now I'm going to take each of these and figure out what I need to multiply by to get that common denominator. All right, so I'm going to start with this first one here, this one. All right, for this one, he has an x plus 1. He has an x plus 4. What is he missing? What is he missing? He's missing a 3, right? My first one's missing a 3. So I need to multiply by 3. Everybody see that? I've already accounted for the 3 down here, by the way, to get the common denominator, right? I'm just worried about what needs to happen to the numerators. So that needs to be multiplied by 3. So for this one, I'm going to have 1 times 3 plus... Now we're going to look at this guy right here, okay? For this one, he has a 3, right? So he has a 3, yes? And he has an x plus 1. X plus 1. What is he missing? X plus 4. So I need to multiply this by x plus 4. That's what that one is missing, yes? So for this side, I have 5x times x plus 4. So far, so good? Now all I need to do is simplify the numerator. And I actually do not make you FOIL out the denominator. Leave it the way it is. Now, if you had 2 times 3, I would want you to tell me 6. But I do not make you FOIL those binomials and distribute the 3 on bottom. I just make you simplify the top, okay? So we're going to simplify the top. We have 1 times 3. That's just going to give me 3. And then we're going to distribute 5x times x is 5x squared. 5x times 4 is 20x over 3x plus 1, x plus 4. Now, I do not want you to leave the numerator that way. What do you think I want you to do with that numerator? Standard form. So my final answer is actually going to look like this. 5x squared plus 20x plus 3. Leave your denominator. I do not make you distribute that. And you are done. All right. So while it looks huge at the top, you're really just breaking it down into factors, deciding that you have used every one of your factors. What factors are you missing? That's what you're going to multiply the numerator by, whatever factors you're missing. Then you're just going to simplify the numerator. So I want you to try one. If you flip the page, top of page 506, you'll see check understanding number 3. I want you to try that one. Honestly, the biggest problem with subtraction is not distributing that negative when you go through. All right, so if you do the same process, you're going to be fine, but just make sure that you pay attention to your positives and negatives here. All right, so we're going to do the same process for this. I can take a 5 out. I get y squared minus 25, which is going to factor to what? Y plus 5, y minus 5, right? And then this one right here is going to factor to 3y plus 5. And so when I get my common denominator here, I'm going to get the 3 and the 5, right? So I have a 3 and a 5. Y plus 5. And y minus 5. And then to decide my numerators, I'm going to do exactly the same thing. The 7y, which is the numerator here. He has the 5, the y plus 5, the y minus 5. What is it missing? The 3, all right? Make sure you put the subtraction here. And then I have a 4. The 4 is missing the 5, right? It has the 3 and the y plus 5. And it's missing the y minus 5. So when you distribute here, you're going to distribute that 20 through. But you're going to make sure you distribute a negative 20. All right, negative 20. So this becomes 21y. We are distributing this guy through, it's 20. So negative 20 times y is negative 20. Is that? So negative 20y. Negative 20 times positive 5 is a positive 100. This is the biggest mistake right here, is that right there. Over, you can leave this, 15 y plus 5, y minus 5, or they may have done y squared minus 5 if you see it, but you don't have to. Combine your like terms. These two are alike. So I have y plus 100 over 15, y plus 5, y minus 5. All right. So subtraction is the same. Just pay attention to that distribution of the negative. All right. Pay attention to that negative. The biggest mistake is this guy right here, not distributing it through when you have a binomial on the other side of it. All right. Complex fraction is, as though I have to explain it. The word complex does it for me. But honestly, a complex fraction is really a rational over a rational. So you have some type of crazy fraction over another crazy fraction. To be honest, you've dealt with complex fractions before. You've definitely dealt with fraction over fraction. What do you do with fraction over fraction? Right, keep, change, flip. So you're just going to do that, right? So yeah, your denominators, if it's the same denominator, they'll just cancel because of the keep, change, flip. But you basically just keep, change, flip. There's actually two ways to do these. You can simplify the numerator into 1, simplify the denominator into 1, and then keep, change, flip. Or you can multiply everything by the common denominator for all of them, and then it will naturally reduce itself. I find that people typically do the first method more often. It seems to be less confusing because they're okay simplifying the numerator, they're okay simplifying the denominator, and then the keep, change, flip is something they've done for so long that's simple as well, okay? And so we're actually going to do that method on this one right here. All right, so basically the method that they're teaching on the second method at the top of page 507 is simplifying the numerator, just like we did with those other ones, and simplifying the denominator, and then keep, change, flip. All right? So for this top one, I'm going to look at the 1 over x plus the 3, and then the 5 over y plus the 4. All right? And I'm going to figure out what my common denominator is individually. So this is over 1. So what is my common denominator up here at the top? What's my common denominator up here between x and 1? Just 1x, right? So my common denominator, I have to use the x and the 1, so that gives me just an x, right? For this one right here, is it missing anything from the common denominator? 1 over x, is it missing anything? It has the x. It's not. Do I need to multiply by anything? No, it's already has the common denominator. What about this guy? Is that missing anything?
Yeah.
Yes, it's missing the x, right? So I need to multiply that guy by an x. Does everybody see that? My common denominator is 1 times x. Yes? This one has the x already. This does not. I just did exactly the process. It was just smaller, right? It was actually a smaller one. All right, let's look at this guy. This is over 1. So my common denominator for him is going to be 1 times y, right? I have to account for the y and the 1. So I'm just going to get a y, correct? My first fraction, is it missing anything from my common denominator? No, so it's going to remain a 5. My second one, is it missing anything from the common denominator? Yes, so I need to multiply by y. All right, those are as simple as you can get them. All right, now I'm ready to keep, change, flip. Does everybody see I can't simplify my numerator or my denominator individually? Okay, so now I'm just going to keep, change, flip. I'm going to keep the top one, 1 plus 3x over x. Okay, I'm going to change it to multiplication, and then I'm going to flip the bottom one. It's going to be y over 5 plus 4y. Everybody see that? Then I'm just going to multiply across. So I'm going to say y times 1 plus 3x. That's my numerator. Yes? And then x times 5 plus 4y. That's my denominator. Now here they distribute because they're trying to make this a little more simple. So I'm going to actually distribute that. Y times 1 is just y. Y times 3x is 3xy. X times 5 is 5x. And x times 4y is 4xy. That is as simple as you can get them.